Hello folks, today we're going to talk about having a web worker running in our React application. So as always, I already started by setting up a create React app, and I already installed the dependencies we're going to need. So let me show you. So I installed Comlink and the worker plugin for Webpack. As you can see, the worker plugin for Webpack is a dev dependency, and Comlink is something we're going to use on our bundle. It's just a very thin wrapper on top of web workers. We're going to have a further look down on it once we start using it. And that's what I already added. Now we need to make some changes to our tsconfig as well. And we need to change something in our webpack because we need to add that plugin. And now I'm just going to run yarn eject. And in most cases, you don't need to eject. And create React app gives you a heads up by saying this, but in this case, I'm 100% sure we need it. So we're going to run this process, and while this do it, we need to have a little talk about concepts before we get started. So there are a few ways of running our code. The most common one is synchronous code. So we have a bunch of tasks, and every time our event loop gets to it, which in this case is the bus, JavaScript engine is going to execute our tasks, and then it's going to go finishing up the queue. Another way of doing that is by async code. So as you can see, there's still only one engine executing our code, but we have multiple lines, which in a way it's different threads. So they don't interfere with each other, but there's still some concurrency happening. The engine is going to jump from queue to queue, executing the first item of each one, and they're going to and it's going to deplete the queue in that way, one by one. So as you can see, in most cases this is more than enough, because yeah, I wouldn't recommend you to have any very long processing in the client side out of the box in most situations. So this is more than enough, but as you can see, there's only one engine, there's only one executioner. So in this case, if you get one of these tasks that gets like takes a long time, it's going to actually block eventually. And then there's this other way of having them multiple threads with actual parallelism, and then you're going to have engines executing the code at the same time. So one doesn't block the other. And that's what we're going to do. So that's basically the difference between a web worker and working with promises or any other asynchronous code, and working with just regular APIs that are synchronous in JavaScript. So web worker is a JavaScript API that allows us to execute code into a different thread. Basically, it splits the thread. Not everything is, not all APIs are available, so it's supposed to be used with heavy processing, and there are a lot of interesting ways of interesting applicabilities of the web worker. And we're not going to dive too much into it because it makes up for numerous videos. So I can dive into the ins and outs of web worker on a different video. Just post a comment down below if you want a deeper dive into what web workers are and what are the kinds of cases that you can use them and what are the cases that you shouldn't use them, and I'll see through it. But right now, what you need to know is that web worker is a JavaScript API that allows you to run processes in a background thread. So it's not going to be a blocking script. It's not going to be blocking the execution of your UI. It's not going to jeopardize perceived performance on your UI. So now let's get to it. So first of all, we're going to go to our tsconfig file, and we're going to set it to be a web worker type, and we're going to replace the target for yes next. And now we're going to jump into our config folder and open the webpack config. It's a very, very scary file, as you can see right here. And what we're going to do is import our script. So as you can see, TypeScript's already saying that this is not necessary. We can just remove it. And we are going to import web worker plugin and require our worker plugin. And now one way to find it easier is just to find for the HTML Webpack plugin. And here you go. So on line 559, we're just going to set, okay, new worker, web worker plugin, and that's it. That's what we need to do for Webpack. Now we can just close these two files. We're not going to need them anymore. And we can start our project. That's it, nothing changed. That's what we had before. Now we're just going to go to our index CSS, and I'm going to add some defaults. I'm going to put the overflow hidden, and I'm going to set some big buttons because we're going to be using them, and just some background with some padding and all that. So it looks a little bit nicer. And that's it. So let's start making the changes to our app right now. So at this point, what we're going to be needing is the use state, nothing of this, and nothing of this as well. And this one, instead of using a class, I'm just going to set some styles here, just so it's easier for you to see once things start getting executed. The background color, when the data is loading, background is going to be orange. Otherwise, it's just going to be transparent. And now we need to create a data. It's just going to be any kind of string, and then in here I'm going to have our first button, which is going to be sync on main thread. And this button is going to have this on click. First sets the data to loading, and then it's going to execute some other stuff later. And same goes for async on main thread, and last but not least, web worker. So right now all buttons are the same, but there they are. To exemplify, once we get the thread actually blocked, I'm going to create this other button. It's just for illustration. And what this button is going to do is just log a boop in our console. So we open our console right here, and as we click, we can see it. Let's leave it down for a while. And now we can create our very long processing task. So I'm going to jump into source, and I'm going to create this utils, just for the lack of a better name. And now I'm going to create this big task, which is going to receive a number, and it's just going to create a new array with the number of stuff we pass. It's going to fill it with numbers. And remember, for this example, I'm not trying to write a performant code, actually the opposite of that. I want this to take longer. I want this to do a lot of stuff because I want this to make a significant damage to my thread that you can actually see it. So yeah, don't do this at home. But that's exactly the point. It's not going to do anything. It's just going to create a an array with a gigantic number, and then it's going to map through all of this and just sum the 0 with the index, and then after this we're going to iterate through all of them again, and we are going to sum all the numbers, and we're just going to log the sum of everything. And now I'm going to create my make data. We're actually not making any data, so let's just run big task. It takes the number and it's going to, as it promised, run the big task, and it's going to return done. And then we're going to create a new one called run big task async, which it's going to be an asynchronous function. So this is returning a promise actually, and it's just going to do exactly the same. So that's what we have right now. And let's see if everything's working. We open it here. We go back to our app. And here we are going to import run big task from utils. And run big test 10. Yeah, so this is the web worker actually, so this is not going to do that one specifically, but let's do this one and this one. Great, so now they're all doing the same thing. Awesome. For the promise one, we actually want to run the async one, and here we need to pass async and then await. So not much changed. As you can see, it's so fast that's just going to we don't even see the loading, but that's exactly what we want, and that's most of the cases on a React application. So that's it right now, and and we can actually render the data here, so we know that it's actually done. So once we run it, it's done. We can reload it just to see if it's still done, and that's it. Now let's go to the fun part. Let's create our web worker. So we go again to our source file. I'm going to create a worker. My worker TS is going to import the expose function from Comlink, and it's going to import run big task from our utils. So what Comlink is going to do is it's going to create this RPC, which is a remote procedure call, which essentially means that it's going to use a proxy to allow us to make computation to the worker thread, to the background thread, without needing to explicitly do that in the code. So by creating this proxy under the hood, we are just making the changes into the main thread, but the proxy is actually making those things into the worker thread. So what expose is doing is basically just wrapping our stuff into the event listeners that the worker needs to have, and then sending our data through a post message for us. And then once we are on our app side doing the changes, it's also, the Comlink also has a function for this that's going to wrap all the event emissions and post messages to communicate those two threads one to the other without us needing to do any big thing. So it's a very tiny library. I recommend using it. The only caveat is that it uses proxy, which is an API that doesn't have support for 11, but you can always add a polyfill for that if you need to use it. Otherwise, you can just create a little bit extra boilerplate. That's fine as well. So now to our worker. What our worker is going to do is just, it's going to wrap our run big task into this object, and we're just going to export a type for our worker, and now Comlink is just going to expose our worker for us. And that's it. That's our web worker. So let's use it right now. So back to our App.tsx, I'm going to import wrap from Comlink. And here's where the tough part starts happening. What the worker plugin in Webpack does is basically it teaches the Webpack to compile the web worker and just add it to our bundle as a worker, because now we need to import it as a JavaScript module. And then once we do that, we can actually use it. So now we're going to create our worker, which is going to use the worker constructor, and we're going to pass the file path of where we saved our file, and we're going to pass as a second parameter an object and with a name and a type, and the type is module. Now we're going to get our run big task from there using the map method from Comlink, and then we're going to import our worker. Oh yeah, it's the type, and then we just need to await this, and this function needs to also be async. And that's it. We have our tasks. It's running super fast, but we can see that the web worker is going to work. As you can see, it even blinks a little bit with the processing. The other ones just go super fast. I'm going to go extreme on this. So instead of 10, we're going to have this gigantic number. So we're going to have an actual big impact on our thread. So get ready. First of all, let's go with the with the synchronous code. And as you can see, I'm pressing the boop and nothing happens. Our UI is completely unresponsive. Just keep pressing multiple times. Nothing's gonna happen until it finishes. Yeah, and there we go. And all our boops just happen. And right now, because they were on the queue this entire time, they could not be executed. So this is what happens in the main thread. We have this long task that takes forever to execute, and everything just needs to wait. The user just needs to wait with no feedback, because with everything's blocked, we cannot send any feedback that what we're doing. Now we refresh. But yeah, that's why asynchronous code exists, right? So again, clicking, nothing happens. And here we go again. Because everything is blocked, so there is still some concurrency happening. So all my clicks are trying to get into the line, but it's just one big task being executed. So synchronous code is really interesting when you have different tasks, different small tasks that you can execute them one by one and they don't block too much. And there we go, all our boops. And now is where the magic happens. Let's see what the web worker can do for us. So it's processing. Our thread is extremely responsive, and it's just happening all the time. So as our user is waiting for all this processing to happen, they can actually continue to work. They can actually still do stuff while we are doing this. So it's literally not blocking the main thread. That's the whole point of the web worker. And once it's done, it's going to be done. Until then, the user can continue to work, and we can provide nice feedback, and we can say if it's taking too long, if they want to terminate, and there we go. So I hope this has been useful. There are tons of applications to use with web workers. There's a little caveat. So there are a few APIs that are not available, and there are ways to actually share workers. Workers can spawn more workers, and it's extremely useful. There are a bunch of use cases. There are a few concerns regarding security that you need to have. So please go to the documentation, read it before going using it. But for this simple cases, it's just that easy to use it. So I hope this have helped, and I'll see you on the next one. Bye.